Hi, I thought I would take a video on how to analyze graphs of polynomial functions because there was a lot of questions in class and people had asked if I would actually take a video on it. So this week in class we have learned a lot about how to use the calculator to determine some things from a graph, such as where the graph intersects the x-axis. These are also known as our zeros or our roots. We've also determined like how to graph them, how to find the increase and decrease, and the local minimums and maximums. So I'm going to go ahead and start with example 1 from some of the work we did in class, and I'm going to type it into my calculator. So if you have a calculator, you can kind of follow along with me. So I'm going to type in 0.2 times x minus 3, and that quantity is squared, times x plus 1. And that quantity is also squared. So looking into my calculator just to make sure that I've gotten everything correct, it appears that I have two, for some reason I had two open parentheses, so I deleted that, and then let's go ahead and hit graph and see what our graph is going to look like. So our graph is going to look like a W, and so now I have to find some things. One thing that I notice about my graph is that it's going to touch at these two places on the graph, and if I look at my my polynomial up here, I can see it's going to touch at 3 and it's going to touch at -1. So I can determine that either by looking at the polynomial, or I can find it using the graph. And because it's touching and not going through, I can't actually, whenever I do second and then trace, which means it's calculate, instead of finding a 0, I need to look at that as finding the minimum. So whenever I press that and press enter, I need to go to the left side of that minimum point right there, and I'm going to press enter. Now cursor over and go to the right side of that minimum point and press enter. Then it says guess, and then I'm going to press enter, and it's going to tell me that I have a point at -1, 0, which is exactly what I get from my polynomial. So that's going to be my x-intercept, but in this case it's also going to be a local minimum. So I'm going to go ahead and put that down as a local minimum too. My next point that I'm going to look at is over here, and so I'm going to press second, calculate, and again it's going to be a minimum because it actually just touches the graph and doesn't go through it. And press enter for left bound. Go to the right side, press enter, and enter again. And it lets me know that I also have an intersection at 3, 0. We talked a little bit about what this means, and this is scientific notation, what you've seen in chemistry. And so 3.84 times 10 to the -12th is actually very, very, very close to 0. And so we just round to 0 because it's 0.000000000. 384. So that definitely rounds to 0. So we have that, and I can go ahead and mark that on my graph as points that the graph is actually going to bounce off of my x-axis. So I put a point at -1, 0, and 3 and 0. Now, looking at my graph, you can kind of see that it has end behavior, and we'll talk about end behavior after I graph it on here, because then I can write on the graph. So let's talk a little bit about, we have our local minimum, again, is going to be at 3, 0, that point. So now let's find our local maximum from our graph. So I do second, trace, which is calculate, and I'm going to go to maximum, go to the left side of that maximum point right there, press enter, the right side, press enter, enter again, and you can see that I have a maximum value at 3.2. So I can use this to go ahead and graph my polynomial. So I'm starting up and I'm going to end up. So this means it's an even graph, and I know that because it's going to be x to the 4th. And I can look at my end behavior now. And end behavior is where is my graph going at the end. And my graph, as I go at the end, from negative infinity, it is going up to positive infinity. So I'm going to write as x approaches negative infinity, y is going to approach positive infinity. And as x approaches positive infinity, y is going to approach positive infinity. Positive infinity, and y approaches positive infinity. So that's a little bit about my end behavior, and I taped another video on that, so you need to check that out sometime to make sure that you know what I'm talking about there. Now, another question that you guys had is you guys had questions about these increasing intervals. Now, I'm going to go ahead and I'm going to put a green, I'm going to highlight that in green so I can highlight the part of the graph that's increasing. So it looks like I have a turning point right here at -1, and from -1 all the way to +1, it looks like my graph is increasing. And then when I get over here to +3 and going all the way to infinity, my graph is also increasing. Now, and this I'm reading from left to right, and it's very important because as I'm moving left to right, that's decreasing, and then this portion of the graph is decreasing. So now I can kind of figure out, okay, so what part of my graph is increasing? So I have this portion of my graph is increasing from -1 to +1, and then from 3 to positive infinity. And then that's the portion of my graph that's green, and that is increasing. So now I have to look at what portion of my graph is decreasing, or is my red portion. And you can see that it starts at negative infinity. So from negative infinity, so that's my x value, all the way to -1, it's going to decrease. And then it starts increasing, but then when I hit this point at x is equal to 1, so and from 1 to this point that it hits the graph again at 3, it makes the turn, it's going to be decreasing. So that kind of gives me an idea of where it's going to increase and where it's going to decrease my graph. Now I wanted to do one other problem for you, and this is actually graph 2, or example 2. So again, I'm going to go to my graph and I'm going to plug in my formula. Remember, when you're using your graph and it has a negative, make sure you're pressing the negative button and not the minus button. It will not work if you do it the other way. So negative x to the 4th minus 2x to the 3rd plus 3x squared, and then minus 4, plus 4x minus 4. So I make sure that I got it right. Negative 4x squared minus 2x to the 3rd plus 3x squared plus 4x minus 4. Always make sure you type it in right, because if you type it in wrong, you won't get the right graph. So then I have another graph, and it's actually a W again. So I have to find some points. And again, it doesn't actually go through the graph at the points that I'm given, but it does touch the graph. So I'm going to go ahead and find those local minimums, which ends up being my x-intercepts also. So I'm going to do second calculate, and let's find my local maximums actually. Go to the left side of my point of touching the graph, and the right side of that point touching the graph. And it's going to tell me that I have a local minimum at -2, 0, which is also where it touches the x-axis. And then I'm going to try to find my next one. I have a local max, oh, I wrote that in the wrong spot. It's a local maximum, so -2, 0. Then I'm going to cursor over and go to the left side of that maximum point, and then cursor over and go to the right side. And then it shows me that I have another value at 1, 0, which is also an x-intercept. So I found my two x-intercepts and my two local maximums at the same time, which works out really well for me. Won't always work like that, but it has this time. The next thing I need to find is the point of my local minimum. So I'm going to do second trace, and I'm going to choose the minimum option and go to the right side, left side of the minimum, and the right side of the minimum and press enter. And I can see that at negative 0.5, and we're just going to round that to negative 5, there's going to be a local minimum. So now I can use these values to graph my polynomial. So I know I have a point at negative 2, 0, where it's going to bounce off, and again at 1, 0. And I know my local minimum here is 1, 2, 3, 4, 5, like 1/2 and 5. Starts low, makes a turn, bounces off again. Okay, so I have kind of drawn my graph here. Looking at this end behavior, so this is going to be my negative infinity. It's going to go to the negative. So as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x is going to approach negative infinity. So you kind of see that. Now we have to find our points of increase. And again, I'm going to do my increase as green, and I'm going to do my decrease as red. So increase, it's increasing from my x value of negative infinity to negative 2, and then again from negative 0.5 to 1. And then it's going to decrease from negative 2 to negative 0.5, and then from 1 to infinity. So from negative 2 to negative 0.5, and from 1 to positive infinity. So hopefully that helps you understand about how to interpret or analyze graphs of polynomial functions.